Now that we've had a look at the ideal gas law, and we've spent a little bit of time identifying what an ideal gas is, we're now ready to move on to looking at some of the processes that are involved in thermodynamics. Thermodynamics is the study of processes in which energy is transferred as heat or work. And we need to clearly define what these concepts are. So, and we already have defined them. We're just going to define them all in the same terms now. So, heat is the energy that's transferred between objects at different temperatures, as we defined in topic 3. And when heat is absorbed, the internal energy of a substance increases. And heat, as all forms of energy are, is measured in joules. Now, in an ideal gas, when we increase the temperature of the ideal gas, we increase the internal energy, and there is no potential energy. So in fact, the temperature is a measure of the internal energy. And so the second term that we need to define in terms of energy is the internal energy. So the internal energy is the energy that's contained within the gas, and in an ideal gas, that's all the kinetic energy of the particles making up the gas. The third form of energy that we need to define, so we've got heat, we've got internal energy. The third form is work, and work is the mechanical energy that is transferred to or from the gas. So when we apply a force to the gas, we can compress it. We're then doing work on the gas. And when we allow the gas to do work on, when the gas does work on us instead, which I'm demonstrating here, the pressure of the gas is causing the box to expand, which means it's doing work on the box. So that's when the gas does work on the environment. And so we have three forms of energy. We have heat, we have internal energy, and we have work. And heat and work are the ways that energy is transferred between the outside world and the gas. We need to define a few other aspects so that we can talk clearly about these situations. So firstly, we have what's called the system. So usually we want to consider a particular system when we're talking about thermodynamic processes, and in this situation the system is this box full of particles, and we say that in thermodynamics we usually break the world up into a system and its surroundings. So the surroundings is the whole universe apart from the box. That allows us to talk about transfer of energy between the surroundings and the system, and it allows us to simplify what we're studying by allowing us to just focus on one thing. Now, we have two types of systems that are of particular interest. A closed system is one like the one that we have here at the moment, where mass doesn't enter or leave the system. So this is a closed system as long as I don't pump any more gas in. So it's a closed system. If I pump more gas in during that process, it's no longer a closed system. So as long as the mass remains constant, we have a closed system. An isolated system is one in which no energy is gained or lost by the system. So at the moment, this is an isolated system because it's not, we're not applying any heat to it, and we're not pushing on it, so we're not doing any work on it. So it's not gaining any energy or losing any energy. So that's what we mean by an isolated system. Those are the basic terms, and those are the terms that we're going to be using in this topic. So it's worth having them clearly defined in your notes to start off with. and we'll get plenty of opportunities to apply them, so they should become quite familiar as we work through the topic.